Okay, let us consider problem 8.59 of Sonntag. We have a rigid insulating vessel, rigid insulated vessel, which contains superheated vapor at 3 megapascal and 400 degrees Celsius. Very good. The valve is opened, allowing steam to escape. The overall process is irreversible, meaning this thing causes irreversibilities, but the steam remaining inside goes through a reversible adiabatic expansion. So state 2 is reached by a reversible adiabatic expansion. Determine the fraction of steam that has escaped when the final state is saturated vapor. So the final state is saturated vapor. The process is a reversible adiabatic expansion. This means ds equal to del q by t plus delta sgen. So this sgen will be 0 because it's a reversible process. This will be 0 because it's an adiabatic. Therefore S2 is equal to S1. Now we must find the total mass that has escaped. So we know because it's a rigid container, the volume is fixed. So M1 is equal to the specific volume multiplied by the the volume divided by the specific volume. M2 is equal to the volume divided by the specific volume. So the M2 is less than M1 because mass has escaped. There was initially some mass M1 and some mass has escaped. Therefore fraction of mass that has exited, the fraction of mass that has exited is equal to M1 minus M2 by M1, which is equal to 1 minus M2 by M1, which is equal to 1 minus V1 by V2. So let's go to ES. State 1, T1 is at 400 degrees Celsius, P1 is at 3000 kilopascal, state 2 is at x equal to 1, S2 is equal to S1. S1 is equal to the entropy of steam at T equal to T1 and P equal to P1. So we must also find out the specific volumes. Similarly, the specific volume at state 2 is found out using the quality and the entropy. Because entropy is also a state property. So we have used X and S as the two properties to find out the specific volume. So the fraction of mass is equal to 1 minus SP wall 1 divided by SP wall 2. So the fraction is approximately 0.7997, so 0.8. So 0.8 mass has escaped. So the problem illustrates a very important concept, that if we only consider the control mass of the system, that control mass undergoes a reversible adiabatic expansion. There are other external irreversibilities to the control mass. So these are fundamentally internal irreversibilities, but they are external to the control mass. These are the irreversibilities which are happening outside the control mass. So these are the irreversibilities outside control mass. And so we do not bother about what is happening outside. For the control mass, it is given that the process is a reversible adiabatic expansion. So the reversible adiabatic expansion goes on until the final state is saturated vapor. The final state is saturated vapor. Final entropy is equal to the initial entropy because the process is adiabatic reversible. Using this, the fraction of mass that has exited can be easily found out using this. So I hope the concept is clear. So this was problem 8.59. All the problems can be found in the Dropbox.